Work and Energy, Module 5. So let's begin. So energy simply means the ability to do work. So wakay energy, wakay work. Di ba ito? It's like how you need energy to move things, to create things. Energy has many forms. So kasi classic mga energy like heat energy from the matches, and you have electric energy sa mga calculator ninyo, sa computer and so on. O ka na sa fuel, sa sakyanan, ginagamit po na siya. It's also an energy. So there's also this concept of conservation of energy. If ang system is closed from the outside environment, the total energy remains the same. It's the same. Meaning wala siya yung mga leaks. Like for example, if we have a very good engine na walay heat na ginaimit niya, then it's a very good closed na system. However, as you know, ang engines mag-generate siya heat and fumes. So di kay siya nga naka-closed ang system. So the sourceable energy as we know it is ang sun. Here on the left, you have in left image nimo na kay sun feeding the plant through the photosynthesis na process. Then you have another animal here eating the grass, and we also consume the animal into a product like a steak. Then ginakaon nato siya and ginagamit nato as our own fuel. I wonder po ganun, why not we just directly absorb energy from the sun? It's not possible. Not possible because we lack the ability to do photosynthesis. Also, can you imagine green tang tanan? The other one is nakay solar panel. So solar panel, it's directly absorbing energy from the sun, then converting that one into electric energy, but it is not that efficient. Too many parameters, which we'll learn actually. Before that, we go to this mathematical method, which is ang scalar product or dot product. So if you have vectors A and B separated by some angle theta, the dot product A dot B is given by this equation: absolute value of A times the absolute value of B cosine phi, and which gives you AB cosine phi. So take note, wala na siya yung mga arrows, so meaning scalar na siya, hence scalar product. Okay. So the conditions that can occur for this equation are three. The first one is when phi is greater than 0 but less than 90 degrees. So if we go back sa figure, so you can have like this one. So ang imuhang A is, let's say your B here. So greater than 0 degrees but less than 90, so nadara. So it's this phi here. This will result to a positive na value. Okay. The next one, if ang phi nimo is greater than 90 but less than 180, then the scalar product is a negative. So you have this one, ang B nimo, then the other one, so greater than 90, so somewhere here. Let's say that's the A vector, and this is phi. So the value sa inyong scalar product is a negative value. And the last one is when phi is 90 degrees. So meaning, perpendicular siya ang ilang relationship. So this is 90 degrees. So this is B and this is A vector. And this gives you a value of 0. So these are the three possible scenarios nimo. Okay. Here are some properties of a scalar product. So a vector dotted with itself gives you a square of the magnitude, or this is A squared. Then commutative property, A vector dot with B vector is equal to B vector dotted with A vector. Distributive property, A vector dotted with a quantity of CD vector gives you an AC vector and an AD vector. These are dot. And if you multiply a dot product with a constant C, so you can see pwede mo siya factor out. So C times A dot B is equal to A vector dotted with CB vector for any scalar C. Last one is that 0 dotted with A vector gives you 0. So dot product of unit vectors. So you have here ijk. If you remember, in Cartesian coordinate, ang imong I would refer to, change color, ano siya, ang imong I hat, then you have your j hat, and you have your k hat. They are perpendicular with each other. So I dotted with I is equal to j dotted with j and k dotted with k. So the angle between them, sa I vector, that is of course 0. Okay, they're lying on the same plane, man. Let's say for example, I hat. So cosine of 0 gives you 1. So this means that the value of the dot product of unit vector that are the same is 1. Well, in the other case, so it's I vector dotted with other than itself, you get equal to 0 because the angle between them sa ilahang tanan is 90 degrees, and cosine 90 degrees is 0. Okay. So here we have a very long equation. So these are vectors in 3 dimension. You will know this because na kay I hat, j hat, and k hat. So these are vectors A and B. Both are in 3 dimensions. So A dotted with B vector, you have the following expression. So you multiply AX with this, you get this. This one with this, you get this. And this one, you get this. As you can see, this one, these two parameters here, they have different na unit vectors, I hat, j hat. And we know from the earlier slides na this one would result to 0 na value because ang angle between them is 90 degrees. So hence 0 siya. This one, the next one is an AYJ, j hat. So you multiply, let me change color. This one is multiplied to this, and to this. So you get AYBX, j hat, I hat, then AYJ hat multiplied by BY j hat. So you have this one. And last one is AYJ hat multiplied to BZK hat. Okay. So again, this one is, they're different. So this one is 0. This one is also different, 90 degrees. Ang ilahang angle between is 0. And lastly mo is kanisha, ang AZK hat. You multiplied with this one and you get this one, k hat times I hat. Then this one, you get this one, k hat j hat, and lastly this one multiplied by BZ. So k hat. So this one are 0. So we are left with this, and this. So you get AX, BX, I hat, which is obviously equal to 1. These 3 are 0. Next one is AY, BY, J hats. Again, this one is 1. Zeros again. And lastly, ang kaning K hats is equal to 1. So you are left with this function. So the A vector dotted with B vector that are in 3 dimension is given by AX, BX plus AY, BY plus AZ, BZ. Okay. Work. So work is given by the expression work is equal to F times D. But this is specifically F dot D. It's a dot product. So careful lang ta kay last time atong gigamit ang variable na W as weight. For this case, we will call this one work. Esensya na nahutdan og variables. Okay. So hence, we need to understand ang function na dot product because it is needed sa work na function. So where F is the force exerted, and D is the distance moved by that force. Ang unit niya is in joules. Okay. So kung lantanin mo, this is Newton times that with meter. So this one is joules. So, we go back sa katong free body diagram of a block. If you remember, itong block na siya forces na interacting with them. Let's say the block is moving in this direction. Na siya the distance traversed. So you have the force. You have the force here. You have the normal force. You have the weight. And you have the friction. The effect is that it causes the sum of the effects is that it moves the block to a distance d. So let's look at the individual forces. Unsay lang mga contribution. First with the force F. So F dotted with D. The angle between the force and the displacement D is 0 degrees. So this gives you cosine of 0, 1. So FD cosine of 0, 1. So that means the work done by friction is given by FD. The next one is friction. The friction is moving in the opposite direction. The angle between the displacement and the friction is 180 degrees. So the same expression, but instead of F, it's Fk dotted with D is equal to Fkd cosine phi. But the phi here is 180 degrees, and this gives you negative 1. So the answer is negative Fk d ang imong work done by friction. Now, considering ang imuhang horizontal na mga vertical na mga forces. The first one is the normal, Wn. So n dotted with d. So is equal to nd cosine phi. Since ang imuhang normal force is perpendicular to the surface, ug ang gitravel sa imuhang block is nasa surface, they are 90 degrees ang relationship. So cosine of 90 gives you 0. So hence, work done by the normal force is 0. The other one is work done by the weight. Again, the relationship between the weight and the displacement is i-specify na po small w. Saan siya na? So WD cosine phi. So the phi angle here is 90 degrees. So again, it's 0. Actually, pwede po. What is that? Pwede po 270 degrees. And you have cosine. Yeah, you can also do 270 degrees. Okay, naman siya dire. But still gives you cosine 270 degrees still results to 0 because ang ilang ang relationship silang angle between them. Okay. Here we have two scenarios. The first one is a walking person. Weird, no? A person walking. Sorry, baliktad class. It's a person walking carrying gifts, and the other one is pushing a box. It says here that energy is not transferred to the box. There is no work done. Why is that? Because ang displacement padulong dire. Pero ang force niya is lifting the box. Pataas siya. Let me see. Pataas siya. So the angle between them is 90 degrees. Here one. This one, energy is transferred to the box. Okay? Ang iyang displacement, let me clear this. Ang iyang displacement is moving here. Ang iyang force is here, somewhat here. So na siya components here na, let's call that one as Fx, Fy. So na ay transfer of energy by pushing the cart. Okay? And the angle here is not 90 degrees. Okay. Now you know. Here we have an example. The question is how much work done is done by the girl pulling her brother shown in the figure if she travels 25 meters. So clearly, ang imuhang D dire is ang 25 meters. Ang force ni Moha is this one, but it is F dot D. So what is the angle between them? Between the displacement is 30 degrees. So 15 newtons times 25 meters cosine 30 degrees gives you this value, roughly this value, 1082.53 joules. Now we have a work with varying magnitude of force and direction. So let's say na kay sort of trajectory or distance paliko-liko siya. Then obviously, ang force po diri naga-vary-vary po siya. So how do you solve that one? To solve for the work by that one, you have to use an integral function. So basically, we're trying to sum up ang mga tiny na mga effects. So it's f cosine theta dl. Okay. Again, the theta again is the angle between f and dl here. So we can simplify this as f vector dot dl vector. Okay. Here we have the kinetic energy. This is the energy of motion that has a unique that has a symbol K or KE. Again, ang unit niya is joule. Ang expression niya is K is equal to 1/2 mv squared, where m is the mass, v is the velocity of the moving body. So if we have like this one, kay mass here, this is the same mass. Start lang siya at from this point here. Then it is pushed by a net force. Ni-travel siya og d, then iabot siya diri. So na siya velocity 1 here or velocity 2 at the other one. So applying Newton's first law, force is equal to mass times acceleration and the equation of motion. So what equation of motion atong gigamit? It's the relationship sa imong acceleration. What's that? Acceleration interpretation, which is v squared minus v naught squared is equal to 2a x minus x naught. Okay. So x minus x naught for this case is just d. Okay, d. So rewriting the acceleration is equal to v squared final minus v naught squared over 2d, hence this one here. So work from the expression f dot d is equal to fd cosine 0. Why 0? Because angle between the force and the displacement is 0. So cosine 0 gives you 1. So it's just fd. Ang f nimo is just mass times acceleration. But your acceleration from the equations of motion is given by this one. Substituting that one here, you get this expression here. So work now is equal to the change in kinetic energy, which is equal to 1/2 mv squared minus 1/2 mv squared 2 minus 1/2 mv squared 1. So because this one cancels out with this, but you have 1/2 factor out nimo 1/2 dira. So mananggikan aning 1/2 nimo. Okay. So that is the work total using the change in kinetic energy. So work total now, we can rewrite this on K2 minus K1 as delta K, just a change in kinetic energy. This is also known as the work energy theorem. The net work done on an object equals to the change in kinetic energy. Next one is the potential energy due to gravity. So gravitational potential energy is denoted by the symbol U. So energy of an object due to its position in the gravitational field with a constant acceleration of g 9.8. Notice that ang g na to dili siya katong negative bitaw sa kuan sa imuhang equations of motion. Here g here is positive. Okay, positive ang gigamit. Okay. So potential energy, an expression here is equal to mgy. So look at the figure. So So na kay mass na move upward. So pag move nimo upward na kay force exerted og na ay counter niya which is ang force by the gravitational field pababa. So ang displacement niya d pataas. Taas man kay gipasaka man nimo ha. So we will call this one, let's say gilift nato siya to a height. So ang d og h I think they're the same. They're the same. From the bottom lang ang height niya. Oh, actually ang d po ang distance. Ano ang displacement. So going back to the expression, force exerted dotted with the height or pwede po ang d is equal to force exerted h cosine 0 because the angle between the height vector and the force vector is 0 degrees. So ang force exerted nimo is just equal to the weight which is mg plus mg. So mgh siya. The work done due to gravity is fg pababa is equal to fgh cosine of 180 because now ang h nimo pataas, ang force by the gravitation paubos, so the angle between them is 180 degrees. So this gives you a negative 1 value. So multiplying that one is just equal to negative mgh because fg is just the weight, so mg. So h here can be re-expressed as the difference of the height y2 minus y1. So work total is equal to the negative of delta U2 minus delta U1 or negative delta U. So potential energy due to gravity. Okay. Let's look at this one. These are two examples. Same sila og height, but the pathways are different. According to this one, the conservative force, if the work done by the force on an object moving from one point here to another point, depends only on the initial and final position. It is independent of the path taken. So they should have the same. Kaya kanisha dali raman siya. It's just mgh. But how about this one? Ang path niya kay pa-curve. Let's examine. So, ang work done due to gravity, since it's moving in a strange na path, hindi siya straight na path, we have to take incremental changes. So it's fg. So fg, it's this one, kaning mg ni mo, dot dl, kanang mga tiny path niya, in this case here, is equal to mg cosine phi, the angle between dl and the force mg. Okay. So phi would be, if this is a straight line, phi would be 180 degrees minus theta. So phi is the angle between dl and dy, this one, dy here. So we have to prove that the negative cosine of phi is equal to cosine theta. So since phi is equal to 180 degrees, kaganina, 180 degrees minus theta, we can rewrite to 180 degrees minus phi is equal to theta. We recall this mathematical na identity. Cosine alpha minus beta is equal to the cosine of alpha, cosine beta plus sine alpha, sine beta. So using that identity, using this identity here, pulihan nato ang alpha with 180 degrees, ang beta with phi. You get cosine 180, cosine phi, sine 180 degrees, sine phi. Okay. So sine 180, sine 180 gives you 0, cosine 180 gives you negative 1. So you are left with this function here. So here, we've proven that negative cosine phi is equal to cosine theta. Okay? Now we need to show that this function, cosine phi here, so cosine phi is equal to dy over dl. Okay, cosine. So cosine phi, ang iyang adjacent would be ang dy. Ang iyang longest na hypotenuse is ang dl. So rewriting that one simply gives you dy is equal to dl over cosine phi. Therefore, dl is dy over cosine phi. Since cosine phi is equal to cosine theta and dl is dy over cosine phi, we go back to this expression here, mg cosine theta dl. So we can rewrite this one as negative cosine phi and dl as cosine dy over cosine phi. So this cancels out and this is factored out here, negative, so it becomes negative mg dy in the interval of y2, y1 to y2. So again, it goes back to this expression. So regardless yun siya sa path taken, magmatter lang isang iyang initial o ang final position sa imuhang gravitational work. Now, let's look at this figure. Here we have a figure of a sphere na nag-move, na launched from the origin, launched from the origin, pasaka siya to the maximum niya. So initially, dili siya zero ang iyang initial velocity. So, pero ang iyang position, why not, na siya sa zero. Clearly, ang iyang potential energy due to gravity is zero. Pero may iya initial na kinetic energy sa pag-launch. So as it reaches the highest part, nahurot ng iyang kinetic energy. So wala na siya velocity, so zero na siya. Pero na-reach niya ang maximum height, meaning na siya sa maximum na potential energy. Okay? So it makes sense. At the middle, you will notice na na-siya height, ug napod siya velocity. Therefore, na-siya both kinetic and potential energy at that point. Not necessarily good na equal, but maybe depende kay na point na the same sila. Okay. So essentially, it tells you gina-convert nimo ang imong kinetic energy towards the potential energy. But of course, when it falls down, gina-convert na po nimong potential energy to kinetic energy. When work is path independent but depends on the initial and final states, the total work done by kinetic and potential energy is shown here. So delta K is 1/2 mv squared minus 1/2 mv1 squared. So K2 minus K1, or basically delta K. And another work output is negative delta U is equal to mgy, y2 minus y1 is equal to the negative of potential, change in potential energy. So if these are equal, so we can equate both. So we have K2 minus K1 plus U2 minus U1 equal to 0. But these are for conservative forces only. We can rewrite and group ang similar na states. Like ang K1 o ang U1 is equal to K2 plus U2. So the sum of the kinetic and potential energy is called the total mechanical energy. Okay. Okay, so this one is the mechanical energy at U1. This one is total mechanical energy at state nga 2. The change in mechanical energy is equal to 0. Okay, equal raman ang duha, kay ang isa nag-gain, ang isa nag-loss, and then later on pagbaliktad, for example, ang kinetic may imong potential, then pag mo balik na siya, imong potential going towards kinetic. So the mechanical energy, the change in mechanical energy should be 0. Now, if only conservative forces are doing work, the total mechanical energy of a system neither increases or decreases in any process. It stays constant. It is conserved if it stays constant. So here we have hindi siya animal, but this is a assumed na path travel. So if a force is conservative if the net work done by the force and object moving around in any closed path is 0. Okay? Kaya ang iyang initial o ang final na state is the same. Regardless on sa iyang path niya na take. So So there's a general form for the relationship between kinetic potential energy and work done by other forces. So K1 plus U1 plus work other is equal to K2 plus U2. Why do we need this work other? Because naman sa ka lang, like for example, heat na napod ang, for example, friction. You can put it there if you want to determine how much other forces na contribution, not necessarily heat, friction, basta in general, other na forces na iyang ma-generate na work. So let's look at this example. A block of mass M slides from rest daw, with no friction, okay? The block is positioned at the top of the incline at an elevation y. So I assume it's this one here. Y. Find the final velocity at the bottom of the incline. So bilang final velocity. So that means you have something at rest here na block ni slide siya, then up to the very end. So at the ground na, find the velocity there. So the first step is, of course, let's draw the problem. So you have V1 equal to 0. So kung wala siya motion, wala po siya kinetic energy. Pero na siya height, this is at maximum, U1, so na siya potential energy. Na siya potential energy. Then as it reaches the bottom, wala na siya potential energy, kaya ang height niya 0 naman. So 0 siya dire, pero na maximum na yung kinetic energy. Okay, all the energy from here is converted to kinetic energy. Frictionless pa gid ni siya. Of course, at the middle, it has both kinetic and potential energy. So let's write the expression. So at the initial stage, K1 plus U1. Final stage, K2 plus U2. So we have here K1 o ang K2, they have identical expression, 1 half mv squared. Same as ang potential ni mo. But for this case, ay mong K1, ang K1 ni mo, wala kay kinetic energy because 0 ang velocity. So this one is 0. And at the bottom, wala na kay height. Kay 0 naman ang height niya. So this one is 0. So you are left with these two. So since na common sa ila ang mass, cancel out ang mass and you are left with v squared, 1 of v squared equal to gy. So we cross ang 2 ni mo dire, hence may mo siya 2gy. So the velocity na function is equal to, at the bottom is square root of 2gy. Nice. Next is the force done by a spring. So energy associated in stretching or compression a spring or steel. So you have this to look at state here. Uncompressed nga state, compressed nga state, and stretched when released. So this is a force done by the spring. So an equation for force done by a spring is given by this one. Fs is equal to negative kx. K is the spring constant, x is the length of compression. So sa uncompressed nga state, ang x ni mo is at 0. At compressed nga state, gipress ni mo siya at x, then pag release niya, yung aning may tabo, i-convert niya ang spring energy towards the ball, ejecting. So energy associated in stretching or compressing a spring, or still called, is called elastic potential energy. When stress is applied to the spring so that it is compressed or stretched into some distance x, naka-experience yan ng stress niya. If the stress is removed, syempre, let go na niya. Let go ninyo, class. Okay. So here we have a spring, indicated by this blue line here. So the first state is the expanded nga state. So pag binat niya, the mass is moved from x1, from this state to this one. So imo siyang gibinat. So you have a force here. Force exerted. So this one, ang imuhang spring na force is trying to pull the mass backwards. The next one is ang released. So when it is released, the mass is moved from x1 back to x2. The force is the same direction sa imuhang displacement D. Here, the force is opposite sa direction sa imuhang displacement. Okay? And of course, this one's a compressed nga state. Ang force na pud nimo, is in the opposite direction sa imuhang displacement. Okay? So let us examine two positions at x1 to x2. So x2 is greater than x1. So ato siyang gi-expand. So delta U is equal to delta U at x2 and delta U at x1. So Fs dot the force of the spring force dotted with x2 cosine 180 degrees. Why is that? Look at x2. So ang imong force is going, Fs nimo going pasulod, pero ang displacement pagawas. So that means 180 degrees ang angle between them. The next one is ang Fs at x1. Still the same. So you have the force of the spring multiplied by the displacement. Multiplied by the displacement. So you have 180 degrees, and cosine 180 degrees gives you negative one ng mga values. So this becomes a negative, and this becomes a negative also, but na negative rate becomes a positive. Positive there. Wait, something wrong here. I think, yeah, this one is positive. My apologies. Ano, sakto. Sorry. Factor out man din na din. Sorry. Eraser. Okay. So here, sorry. So here we factor out ang negative. So this becomes, why? So here we factor out the negative. So this becomes ang U2 becomes a positive. Ang U1 becomes a negative. Why is that? Para masulat natin yung change in delta U is equal to the negative work done by a spring. So work elastic. Oh, okay. This is nice kay combine nato mga scenarios. So a block with mass M is pushed against a spring that has a force constant K. So kani siya. Na siya is spring constant na K. Compressed at a distance from its equilibrium position. The block is then released. Nabuhian na siya. So mudagan siya. Pasaka. Along a frictionless na horizontal surface. Okay, walay friction dili. And up a frictionless na incline angle nga theta. How far up the incline does the book travel? Not the book, the block travel. So, pangutana, how far up? It's the distance. Let's see. Let's break down the scenario here. First one is ang kinetic o ang potential energy. In the first case, wala kay kinetic energy kay gi-compress siya, ang velocity niya is 0. Wala siya. Then, pero wala siya potential energy due to gravity kay di man siya elevated, pero na siya spring here. So na siya elastic potential energy. So you have the source na imong energy. Then once it was released, nisaka siya, then i-reach niya kanidiri at maximum na height nimo Then stop na po dahil siya, wala na po siya kinetic energy, pero na siya potential energy due to gravity. So it's the elastic potential energy here we convert into gravitational potential energy there. Okay, let's look at this. We then recall the expression. So first is ang kanisya, ang K2 plus U2 is equal to K1 plus U1. So ang ato ang K1 o K2 are essentially non-existent kay nagsugod siya, i-compress pa siya yung mga velocities. Pero ang imuhang at U1 which is the elastic potential energy kay spring man ang gigamit to push the object. Then so na kay 1/2 kx squared here. Then pag reach sa top, ni stop na siya, na convert na into gravitational potential energy ang imong elastic potential energy. Of course, along the way, if ipa-measure ka sa in between nilang duha, na siya kinetic energy. But here, ang concern nato is ang initial o ang final position. So, the equation now is reduced to these two terms here. mgy2 is equal to 1/2 kx squared. y2 is equal to, rewriting the expression, y2 is equal to kx squared over 2mg. This is just the height. The height, pili pa ni siya ang distance travel. So, we have the height here sa y2. But we want to know ang kaniyang distance here, traverse niya. Luckily, we have the angle theta here. So we can use sine theta. Sine theta is equal to the opposite h over the hypotenuse d. Rewriting d is equal to h sine theta. So we know ang h nato is, which we solved earlier, which is ang y2 is kx squared over 2mg. So d now is given by this expression here. Now, for power. Power is simply the rate of change of work, and it is a scalar quantity. Power, of course, scalar quantity can work mo. Scalar naman daan. So, power average is change in work over change in time. Instantaneous power is the limit of the change in work over change in time as the change in time approaches to zero, or simply the derivative of work over time. Unit of power is in watt, which is 1 joule per second. So calculate the average power generated by a 60 kilogram person climbing 2-meter high flight of stairs in 7 seconds. Repeat the calculation for the same person running the stairs in 2 seconds. Step 1. So we consider the point of origin sa ubos. So na siya height na 0, na siya weight na mgh. This is not work. This is weight ni siya. Okay? Oh wait, is it? Oh no, it's it? Tingnan sa iyop ko. This is potential energy. So wala siya work dire kay height niya is y10 man siya. And this one is at work din siya, work mgh, which is at, I think nakupira na ako ni siya, sorry. So mgh, ang h niya here is 2 meters. Okay, so essentially gravitational potential energy. So let's look at this one. Work done by gravity, u is equal to mgy2. Wala man kay mgy1. Okay, so work done by gravity is 60 kilograms, 9.8 meter per second squared times 2 meters. This gives you the amount of work. So the power average, the change of work over change in time. So 1,176 divided by 7 is 168 hours, watts for the time in 7 seconds. But if you run the stairs, divided by 2 seconds, mas higher ang wattage niya, 580 watts. Niwang gid ka na. Okay. And that's it. Thank you very much for listening, and you can contact me if you want, or talk to your advisor, talk to your teacher. And ingat po, and God bless.